everybody, and welcome back to the Moshix mainframe channel. This is Moshix. Over the years, I've received many requests to make a video about remote job entry, a protocol to submit jobs, batch jobs to MVS, and I've never really done that. I've made many videos on network job entry, which is a different protocol, very different use case, but I've never made a video on remote job entry, and René Ferland offered to make one, and we like René's calm, precise way of explaining how to do things where there's complex configurations involved. And so thank you very much for doing this, René, and over to you for remote job entry.
Hello everyone, this is René, and today I would like to talk about a topic that bugged me for a long time: remote job entry. Not network job entry, but remote job entry. What is it exactly? Let's check in Wikipedia. Remote job entry is the procedure for sending requests for non-interactive data processing task or job to mainframe computers from remote workstations. What kind of remote workstations? Well, the IBM 3780 is one of them. I chose this one because that's the kind of workstation or remote job entry workstation I came across in my life. I remember that when I started programming in my university days, I would punch my programs on cards and I would bring my card deck to a guy operating exactly that kind of workstation. He would put the cards over there, I guess, in the card reader. The job would be sent to the computer or the mainframe, which was located in another building, and then the output would be sent back to this workstation, printed on the printer there. The guy would then take the output and the card deck and bring it back on a shelf somewhere, on shelves somewhere, and I would take the output from the shelves and examine the result. Okay, now this, as I said, this workstation was located in a building actually different from the mainframe, a distant building. So there was a line connecting this workstation to the mainframe. It was probably or possibly a line of this kind, a binary synchronous communications line. And that line would lead, I assume, to a controller, which would be an interface between the mainframe and that workstation. And what kind of controller? The family, one family, available family at the time was the IBM 2700X. There was the 2701, 2702, and 2703. Now, why do I talk about this? That's because if you look at the documentation of Hercules, we learned that Hercules provides preliminary, in fact, support for 2703 BSC lines. In other words, it played maybe the role of that controller. So what it means basically is that if I have a program that can emulate a workstation like this, on a computer, I could possibly connect this program to Hercules and have jobs submitted to MVS or another operating system running under Hercules. Okay, so do programs like this exist? Yes, I know of two. There is one written by Dutch Owen, a guy from the Netherlands, that runs on Windows and can connect to MVS or VM for that matter. And there's another one, a Java program written by James Gay, if I'm right. This one runs on Linux, Mac, or PC, but it connects only to MVS. But I'm not going to use these programs in this video because we have VM370. And if we look at the documentation of RSCS, we learn something interesting. On VM370, we have three components: CP, which runs the virtual machine; CMS, which is an operating system; but we have also RSCS, the Remote Spooling Communication Subsystem, which can be used to connect computer or connect to other computers, or we can connect remote job entry stations to it. Or even better, if we look at the documentation of this thing, no, not this one, sorry. I'll be back to this one for, but this, no. This. That's the documentation. Let me go to page 1 maybe. First, that's the Remote Spooling Communication Subsystem User's Guide, the one we have. And if I go back to that page, 105 if I'm right, we learned that we can use RSCS as a remote job entry station. So basically we don't need another program written by somebody. We can use RSCS as remote job entry station. So that's what I would like to do in this video. I would like to use RSCS as remote job entry station, but I would like to connect them to mainframes, remote mainframes. So where are my remote frames? Let me hide this maybe. Well, they are over here. Okay. What is this? This is I'm recording on a Macintosh. And this is an old machine connection to my remote mainframes running on my PC laptop just by my side. Okay, so there are two systems there. Okay, this one is well known. That's MVS 38J as delivered by TK5 Update 3 and running under the Hercules simulator. The other one is this one, NOS 287. That's an operating system for the control data mainframes, and it is running under the desktop Cipher emulator. So what I would like to do from now on is set up VM370 on my Macintosh, and more precisely set up RSCS on my Macintosh and use it as a remote job entry station to these two operating systems, and of course submit jobs and see if we can get the result back. Okay, so let me hide this for the moment. So of course we need VM370. Now the first time I talk about VM370, it was 6 years ago, and since then the situation slightly changed from that video. So if you want to get VM370 now, the latest version is what we call VM370 Community Edition. So you go to this web page. Maybe I go to the home first. Hey, okay, this one, VM370.org. There is a tab for DOSVS and VM370, so I was there first. In this tab, you learn about the 3 versions. The latest, of course, is the version 1, release 1.2. I was there just a few seconds ago. And if you go down this web page, completely down, you have this zip containing the latest version that you can download. Okay, so I did that. That gave me this zip we see at the bottom here. You unzip, you have this folder. Okay. So now what I'm going to do, what do we have to do? Well, the first thing is to set up the lines, because they're not by default there, and it depends on the machine anyway, so the address and things like that. So I have to basically open this configuration file over there, and I have to add the lines. So I'm going to show you the lines. Here they are. I took a bigger font so that they're easier to see. So there will be 3 lines, okay, that I'm going to add to VM370. VM370, the DMKRIO, non-DM370, has, already those lines available. So they are on address 40, the up to 4F, and I believe 9.0 up to 9F, something like that. So I'm going to use these three. The first line will be a connection to MVS, the second to NOS, and the third, I'll be back to it. It's a dial-up or dial-in entry for VM370. So the syntax is quite easy. You describe the IP address and the port of the local host. In this case, that's my Macintosh. The address is 226, and the address of the PC is 224, 24 there. And these ports, well, they depend on the operating system on the remote destination. So the port for MVS is 37801, and the port for NOS is 2555. We need ports locally, but I chose this. You can choose whatever you want, but I chose 78, 40, 41, 42 because of these things. So I have first to add this to the configuration file. So let's do this. I copy. I go back here, maybe before the terminals, maybe. All right. I save that, and now I can start. VM370. So this I won't need anymore. Maybe like that. Now I want to start VM370. Where am I? I believe I am in the right folder. Yeah. I have to adjust the path because let me check. What is the path? I don't think I have Hercules in it. No. So let me add Hercules to it. I have several versions of Hercules, so I don't define one by default. VM user Hercules. Let's say Spinoc. That should be good. Like this. And then I'm gonna start Hercules on this particular file. That's Spinoc for network geometry. It's going to work with SDL Hercules, Hyperion and everything. That's fine. Okay, so that's a brand new, freshly downloaded VM370. So we have an error here. Oh, sorry. We have an error concerning the error recording file area. Okay, I don't know why they distribute a system with that area full, but anyway. So we're gonna deal with it. Okay, so first of all, we start at 3270 connection, or maybe over there, and then I'm gonna log on to maint. What do we have here? Files. These are monitor files. I don't need them. We don't have the software to read them anyway, so let's purge them. Okay, now let's take care. Let's take care of this error recording over there. They say run CP rep, so we're gonna do that. But first, we need a file def like this. Dummy. No. That's the wrong command. Let's see, def dummy. Good. Now CP erep. What do we do? Clear, return, then return. That's it. We just clear that area. It's possible also to save it and print it if you wish, so you have to look at the documentation. The next step is to update the entry, the directory entry of RSCS, because we have defined lines in Hercules, but we need to properly set up the nucleus of RSCS. So, but before that, we need to update the directory entry so that the lines are available to the virtual machine. So let me edit the directory. I will use the old editor. I'm very used to it. So RSCS. You see, you can see there is a line on 040, but the other one, 41 and 42, they are commented. So I want to, change that. So now the lines are available. Okay, so I save that and I quit. But then I have to update the directory online. So I do direct user. Now the directory entry is okay. The next step is to rebuild the RSCS nucleus. Why do we have to rebuild? Because we have to define the lines, or maybe to give meaningful names to the lines, but we most importantly have to change the system name, because the current version of the nucleus use an old system name, and it doesn't use this system name here, which is VM370CE. So we have to rebuild it, but that's okay. There is a file that explains the whole thing. It's on B. You see there is a RSCS memo. So I encourage people to read it to understand how to rebuild the nucleus, but it's not very complicated. So let me do it with you. I think I have the procedure here. So maybe I show it. Okay. So now you can take a look at it. I already purge everything. Okay. So now what I do, I release A, and I will access 591 on A. What's on it? You can see there's a bunch of copy files, a maclib, and some text files. Okay, so we want to update those copy files over there, those who define the links and the lines. When we want to rebuild the maclib containing those copy files. And after that, we want to update this DMT-sys, which is the configuration table. Okay, so let's do that. First, we need to edit ASX links copy. Okay, so let's do this. This is the links. Now you see the ID here is 6-pack, but that's not good. We want to change that for VM370 CE. Now, the other three are actually good as they are, but maybe the names are not particularly meaningful. Normally, what we are describing here is a link, not a node. Okay, so the ID is the ID of a link. However, this link leads to a node for sure, so in a way we can describe the link by a name or by the node to which it is connected. I believe that's the version of AXS links given by Dave Wade, if I'm right. So he just chose three names, you know, node A, node B, node C, but I'm going to change that for MVS, for NOS, and from dial-up, and this way we're going to see if the change has been done. So let me do it just to make it more meaningful and easy to understand. So first of all, I change this node A to MVS 38J. Down, I change this to NOS, NOS 287. Oh, forgot about this, but it's okay. Down, and I change this for dial-up. Dial-up. Okay, so the first two lines are type DMT SML. SML stands for spool multi-leaving. That's the kind of lines you want if you're using RSCS as a remote job entry station. But the last one is of type DMT NPT. NPT stands for non-programmable terminal. So it's a line to connect a non-programmable terminal to VM370. Now, what's a non-programmable terminal? Well, an IBM 3780 is an example of that. So essentially, that line is what we use if we want to connect a remote job entry station to VM370. Okay, so that should be good. So I'm going to save this and quit. Next, I want to edit lax lines. There's only one and not the right number, so let's change this to 40. And now I'm going to add the other two. 041. Gen line equals 042. Save and quit. Okay, so now we're done. Now we go this. So we want to rebuild. Okay, so the first thing is to set up the system for this rebuild like this. You can see there's a bunch of mini disks that's going to be added to the virtual state machine. First step is to update the macro library, the maclib. So we use vmf mac, dmt lock, dmt lcl. That's fine. Then we rebuild the configuration table, vmf asm, dmt sys, dmt lcl. Now he's complaining about this missing maclib, but it's no problem. We don't need it. Okay, so that's fine. And then we have to rebuild the nucleus itself. So cp spool pun tar, cp spool prt star, and then we rebuild. Actually, we're going to load it into the card reader and IPL from it. DMT load, DMT LCL. Good. We can see a lot of DMT. Well, DMT is for RSCS, DMK is for CP nucleus, and DMS is for the CMS nucleus. Now the load deck has been stored in the virtual reader, so we're gonna IPL from it. Let me clear IPL 00C. Do you want to rewrite the nucleus? Yes, I want. Yes, I do. Where do you want to rewrite it? Well, on 591, that disk we've been using so far. Where on 591? Cylinder 4. And do you want LCL cylinder 0? Yes, because we want to IPL from this mini disk. Good. Now what do we do? Well, we go back to CMS. I'm going to release A again, access 1A, and then I'm going to close the reader and read card the map of this nucleus. I'm going to save it. Maybe there is already one, so that's good. Just by the way, let's take a look. We have all this with the map, and then if I do Q disk like this, you can see that this 591 has actually 4 cylinders. So it's cylinder 0, 1, 2, 3, but we said write it on 4, which actually is on the mini disk, but just after this these cylinders which have been formatted for CMS. So basically the first 4 cylinders are CMS formatted, and the 5th cylinder, which has number 4, contains the nucleus. So that's why we can we can IPL from that mini disk. Okay, so at this point I don't need it anymore. Good. Now, before I go to make the connections, I want to submit jobs, so I don't need this, I guess, anymore. I want to submit jobs, as I said, but RSCS, there is no interaction, there's no interactive interface for it. So what we have to do is basically we have to use another virtual machine on VM370, let's say CMS user, and we have to store jobs there and send those jobs to RSCS for execution to the remote computer. So I'm going to use CMS user to submit jobs, but I need jobs, of course. So let me log on to CMS users first. And then I need to create jobs, but I'm not going to create right there. I already created those jobs on my Macintosh, so I just want to send them to the to VM370 and store it on the CMS user virtual machine. And now I realize that I forgot something here, so maybe I do first of all, oh yeah, devinit 03C 3505 dev ASCII trunk end of file. So now I can use the socket reader to read jobs. I'm gonna reinitialize the printer on a socket 2. I'm gonna connect a printer on it. So how about this virtual 1403 that was written by Matthew Wilson and Moshix. So maybe let me go this. Whoop. All right. So the connection is successful. Now I'm gonna start everything. And you can see there are two outputs already. Those are the assemble we made before, basically. So I'm gonna delete them anyway. I don't need that. Good. Now I'm ready to send my job. So here, I created two jobs, and one for MVS and one for NOS. So if I do cat MVS job, it's just a standard job for a Fortran program selling Hello World. So that's fine. And there is one for NOS too. It's pretty similar. Hello here is the job name. That's the account information for NOS, and then I call the Fortran compiler. This is the program, and that's it. So that's pretty much it. So let me submit MVS like this. Good. So I'm gonna read this. That's hello MVS, and I'm gonna submit NOS job. Now this submission will essentially send the job to VM370, the card reader, the socket card reader. Now CP cannot run a job, it can only send jobs to virtual machines. So that's what it's doing. Because I have this, as you could see, you know, the first line is user ID, so that's the user ID card. VM, you use that to say, okay, what's after that? I have to send to this virtual machine. So that's good. Now I can read card this. That's NOS. No, that's hello NOS. Good. Now I keep this. Maybe I start now. Maybe a new tab. How about that? And now I'm gonna log on to RSCS. He's gonna IPL 191, so he's gonna IPL not 190 but 191. That's the RSCS nucleus. That's good. And if I do query system, I can see my links. So the nucleus has been properly updated. So now I'm ready, almost ready. I have to start the line, to connect to MVS. So I will start with MVS maybe. Let's go to MVS. Now over there, let me do star DU. You can see a bunch of unit record devices, the reader and the 3 printer, the punch, but there are 4 lines here though. Those are lines for remote job entry connections. So I'm gonna start the first one. The port is 37801 as described. Okay. And I'm gonna make the connection. Okay. So I start the line 1. Asp OK. I do DU. The line is active. Good. Now back here. I have to start my link, which is MVS 38J, but I have to give some parameters. Parm. First, the kind of node there is at the end of the link. That's a job entry subsystem node, if you wish. So this is described by H like this, and a number, which can be whatever you want, but let's say 01. And then I also have to give the size of the buffer, and that was causing problem in the past when I discussed this with Moshix when we met in Montreal, because we didn't know exactly the size of that buffer. But finally it turns out that 606 seems to be good. Okay, maybe some other values are good. The default value is 400, but it doesn't seem to work with what we have. Okay, so but this one I believe is good. So let's see what happens. Woohoo! So connected. If I check over here, you can see the incoming call. Okay, so my Macintosh running VM 370 is now connected to the MVS running on my PC. Now I want to submit a job. Okay, so maybe I clear this first, just so that we can see what's happening. I'll come back here. Okay, so what I'm gonna do is basically punch the job to the RSCS virtual machine. But then again, I want this machine to send the job to MVS. So I have to tag the job with the name of the link. So this is done with the tag command, which is a CP command. So I tag my punch, with the name of the link, which is MVS38J. Then I spool my punch to RSCS, and now I can punch my job, which is hello MVSA without header, and let's see what happens. Okay, so he's sending. Is it working? Yeah. Now he's receiving. Yeah, actually it received completely, because as you can see, he printed my job. Now let's take a look. It ran on MVS. That's what it came from the reader, that reader of the remote job entry, the first remote job entry station, and it sent the output to the printer of that remote job entry line, if you wish. And then over here in Hercules, you punch, and then it's now the job is not returning back to CMS user. It's gonna get printed. Okay, because I don't think the version of RSCS, that nucleus is it's an old version that does not support this. Today, it's possible to get the result, back to the virtual machine. But on VM370, that's not the case. But however, that's pretty much the behavior of a remote job entry station anyway. You just bring a job and it prints the output. No, it doesn't send the job to something else. And now I should see my job. Okay. Well, actually, I have two. The first one is a kind of an acknowledgement, See, there's just one line like this. The second one is the job. So RSCS MVS 38J, and then my job and everything, and the output. Okay, so I sent my job on my remote computer and it was executed and I got back the result. Now let's do the same with NOS. Okay, so back here, first of all I have to cut this line just to technically I believe we could define several lines at the same time, but when I tried that I ran into some trouble. So just for the sake of this video, I'm gonna do one at a time and proceed very cautiously so that I'm not stuck around the way. So first of all, I have to shut down this line. So from MVS, so that's $PLN line 1. Line is drained, that's fine. And now over here, you can see that everything has been disconnected and the link is deactivated. If I do a query system, nothing is active. So just to play safe, let me re-IPL the nucleus. Good. Now most probably the lines are clean now. Now I want to make a connection to NOS. Now this one, I don't need to start anything, but you need this thing, this RBF to be running. RBF stands for Remote Batch Facility. So if you have a full equipped NOS 287 that you build, I'll come back to this. I believe that RBF will be already there, but there's some stuff to do. I was discussing this on Moshik's Discord channel lately, and I'll come back to this at the end of the video, but quickly. So this NOS is ready to receive a connection, a remote job entry connection from VM370. So let's do that. Okay, so I'm gonna start NOS 287. I need to specify the parameter. Now that's ASP job entry subsystem, or a ASP kind of link too also. But the buffer is going to be the standard size. Okay, maybe it works with something bigger, but I'm not sure. Okay. Woo! Now NOS is answering. That's fine. And I get this ready message, which means he's ready to get the jobs. Okay, so let's go back here to CMS user. Now the spool is okay. We punch to RSCS, but the tag is wrong, so I have to change the tag. CP tag device the NOS 287, and now I can punch my job. We can see it's working. Receiving, that's good. It's coming back. Good. If I take a look here, you can see that the job has been run. See the job hello, the Fortran compiler, and then the execution. If I take a look at the output, it's there. And this is the output. That's the front page for the execution on NOS. Here's my program, and right down here is the hello world, so it runs. Huh? So that's fine. Okay. So that's one thing. But remember, we have also this dial-up. Okay, so I'm gonna stop this link. So I have to drain it. Drain NOS like this. That's gonna deactivate. This was done automatically for MVS once I shut down the line, but here I have to do it explicitly because I'm not shutting the line on NOS 287. I'm gonna re-IPL just to be safe. That's it. And remember, we have this dial-up line. So let's use it, okay? Because if you look here, we have at the bottom RJE 80. Maybe we can it's difficult to see, but it's there. You know, that's a remote job entry client, the one of Dutch Owen. Okay, so this one can connect to VM370. So I'm gonna use this to connect this client to the VM370 on my Mac, and I'm gonna run a job on it. Okay, so let's do that. Let's start the dial-up, and I'm not gonna provide any parameter. That's gonna be the default parameter. They're fine. Now he's ready for a connection, so he's waiting for the client to connect. So let's try to do this. I go back here. I'm gonna put it down like this, and then I'm gonna start this guy. Okay, now you go to options, you give here the name of the host with the port, and you choose the kind of operating system. You can see that you can be MVS or DOSVS or even the old OS 360 or VM 370. So I chose that. And then you specify the address over here with the port, and then you connect. Okay, so let's connect. And it says connected, so let's check. Yeah, it's connected. But now I have to sign on. When I had these two previous connections, you know, with MVS and NOS, there was a sign-on, an automatic sign-on done from the parameters of the start command. But in this case, I'm not using a start command to connect. It's the program to connect, so I have to sign on, okay? But fortunately for me, let's go back here. There is a sign-on card for this, so I load the sign-on over here. So I do a sign-on on dial-up. This is the kind of remote job entry station I have, and this PCHY, it means that the remote job entry station has a punch also. And so I'm gonna send this thing to VM370 to sign on, okay? That's gonna take some time. Sending. Is it gonna work? Yeah. And now you see here, sign on link dial-up complete, and actually that's the case here also. So now I'm ready. You know, the connection is complete and the sign-on is done, so technically I could submit jobs. Now, of course, RSCS cannot run jobs. So I have to send a job to RSCS and ask RSCS to submit this job to another virtual machine that's going to run the job, and that virtual machine must send back the output to RSCS, which will send it back to the link, okay? So let me show you an example of a job. Okay, I'm going to use this. So I clear this and I load a new job. Now, I don't have any virtual machine, interesting virtual machine like DOSVS, for example. That's what I would use it. But so I'm going to use CMS batch for it, okay? Let me open this. Okay, so now you can see again, okay, the first card is the virtual machine to which I want RSCS to send the job. This has to be coded very strictly, you know, with the name in column 16, if I remember well, like this. And then what I have, I chose CMS batch. What I have here is a job for the CMS batch virtual machine. So the first card is the job card. And then after that, the job is very simple. In this case, I'm going to ask CMS batch to link the CMS user 191 minidisc and list the files there. Okay, that's all. That's what the CMS batch will do. But again, you need, as you said, to send back the output. So what I do, I'm going to spool the printer and the console to RSCS. And of course, I have to tag also the output with the name of the link, which is dial-up in this case. Okay, so that's what it happens here. So maybe I clear this. I come back here. And I try to send this job, crossing my fingers. Oh, that bing, bing, bing here. You got it? You send the file. Okay, so let's go back here. Over there. I got the output. Okay, so CMS batch facility. We have all the tag, the spool, and the commands, and then I have the list of the files, including my 2 LO jobs that I just loaded on this system. Okay, so let me clear this first, and now I'm gonna disconnect my client. Disconnect. I'm gonna come back here, and I'm gonna drain the line. Good. At this point, I'm done with my demo, if I wish. So I'm going to log off. I have to escape to CP. There's no log off command in the RSCS, so I escape to CP to perform the log off. Actually, there is no log off command in CMS either, but you just send the job and the command to CP because he doesn't know about it. All right, so that's good. Okay, let me clear this and log off again. Now over here, maybe I clear this and close this. Good. Let's go back here. Oh, maybe not. Maybe right there. A few words about this guy. Okay, about the DT, the NOS 28. I made a video about NOS a few years ago, and again the situation changed since then. So just a few words about that before I finish this already pretty long video. If you go, not this, to maybe Google, and then GitHub KEJ715. That's the Nostalgic Computing Center fork for DT Cyber. This is the GitHub that contain everything regarding NOS and also the emulator. So if you want to build the emulator and the operating system and use it like I did, what you have to do is to clone this repo and then compile and then go to the folder here of the operating system and perform the installation. Now this is very well documented. There's a complete README here that explains everything on how to build a simulator. Okay, and then when you go over here There's also NOS 287. There's also a README that explains all the steps, how to install this and how to use it. And there's a lot of stuff that can be installed and explore. And this is very well done. So it's worth reading this carefully, slowly, and learning everything on how to install this operating system, on Linux, on the Macintosh, on the PC. And I was successful myself in installing it on a PC and on my Mac. So if I can do it, anybody can do it, I would say, because I'm not an expert at all, but this is very well documented. Now, to install, you need Git. You need also Git LFS, the large files system. You need Node JavaScript to run the JavaScripts, and of course a C compiler. But if you have all that, and then you clone the repo and you start from there, you should be able to do that. To build NOS 287, you can build the whole thing, the whole shebang, complete with everything. I myself build essentially the basic version, but you can build the whole thing, and you will have everything available, not only remote job entry, but all kinds of funny stuff to explore. And there is even a little bit more to do, because you have to add a site config and reconfigure, but this is also documented, if I'm right. So anyway, we can discuss this later. All right, so I'm gonna stop here because that's pretty long, I believe. Hopefully you had fun watching this and you can try to explore that. What I wanted to do with Moshix a long time ago was to start remote job entry on VM370 and connect to MVS, and this is what I was able to do recently only, the way I just exposed. So I'm done now. Back to you, Moshix.
Thank you very much, René. Amazing work as usual, and I'm sure that our viewers will appreciate you creating this video. I was following along, and everything works exactly as you said it, so no surprise there. And I think it's been very helpful for all those people out there who would like to try remote job entry. It's just one more way to explore our MVS operating system and all the amazing things we can do with it. Thank you everybody for watching this video. Thank you, René, and see you soon again. Goodbye.